Welcome everyone. In the next few minutes, we shall review some concepts on the levels of evidence and the interpretation of a systematic review. There are many systems to classify levels of evidence, such as Canadian Task Force, the GRADE system, etc. Let us see one such system here. Evidence level 1A is constituted by systematic reviews free of heterogeneity, either in direction or degree of effect. Level 1B includes good quality randomized trials where the confidence intervals are narrow. Level 2 evidence comprises either individual cohort studies or systematic review of cohort studies where the follow-up rates are above 80%. Level 3 evidence arises from either individual case control studies or systematic reviews of case control studies. Whereas level 4 evidence comprises case series and poor quality cohort or case control studies. Note that cohort studies are said to be of poor quality if comparison groups are not clearly defined, exposures and outcomes are not measured in the same manner, confounders are not appropriately identified and adjusted, or if follow-up is insufficient. Level 5 evidence consists of expert opinion without explicit critical appraisal. Systematic reviews occupy the highest level of evidence. Let us look at them in little more detail. The term meta-analysis is often used interchangeably with systematic review. Meta-analysis is actually a statistical technique used to combine the results of several studies addressing the same question into a single summary measure. Systematic reviews do not always have to have a meta-analysis. The Cochrane collaboration was established in October 1992. It is an international non-profit organization that prepares, maintains, and disseminates systematic, up-to-date reviews of healthcare interventions. Forest plots are graphical representations of the meta-analysis. The word originated from the idea that the graph had a forest of lines. The plot originated in the early 80s, although forest plots in their modern form originated in 1998. Let us look at this forest plot of the studies evaluating the efficacy of magnesium sulfate given antenatally to prevent cerebral palsy in infants. Each study is represented by a line. We can see that there are 4 studies in this meta-analysis. The names of the individual studies and the year of publication are indicated on the left. There is a box in the line for each study. The midpoint of the box represents the point effect estimate, that is, the mean effect estimate for each study. The area of the box represents the weight given to the study. This is designed so that the eyes are drawn towards the studies that are given more weight. The diamond below the studies represents the overall effect. The width of the line shows the confidence intervals of the effect estimate of individual studies. The width of the diamond shows the confidence intervals for the overall effect estimate as indicated in the figure. What do the point estimate and the 95% confidence intervals mean? Point estimate is a best guess of the true effect in the population. The 95% confidence intervals mean that there is a 95% chance that the true effect in the population will lie within this range. They also mean that if the trial is repeated, there is a 95% chance that the point estimate from the trial lies within this range. These are based on the sample being representative of the entire population and the assumption that there are no systematic errors that can bias the result. There is a vertical line which corresponds to the value 1 in the plot shown. This is the line of no effect. This means that the intervention neither increases nor decreases the risk of developing the outcome. Note also that effect estimates lying to the left of the line favors the experimental group and those to the right favor the control group. This label, however, is interchangeable. If the line of no effect is included in the 95% confidence intervals, it indicates that there is no statistical significance for the effect of the intervention. If the line of no effect is not included in the 95% confidence intervals, the results are statistically significant. This is applicable for the effect estimates of the individual studies and for the overall estimate. In the given example, the 95% confidence limits of the pooled estimate extend from 0.55 to 0.91, thus not crossing the line of no effect. In other words, the intervention has a statistically significant effect on the outcome. More specifically, the pooled relative risk favors the intervention group as there is a 29% reduction in the risk of cerebral palsy. The forest plot also provides the summary data entered for each study. In addition, it provides the weight for each individual study. The method and the model used to perform the meta-analysis is indicated here. For example, this meta-analysis has used the Mantel-Haenszel method and fixed effects model for performing the meta-analysis. Another important consideration in interpreting the forest plot is heterogeneity between studies, which is indicated here. In general, heterogeneity is taken to be significant if this parameter I squared is greater than 50 to 60%. The random effects model is used if heterogeneity between studies is significant, and in other cases, the fixed effect model. In case of quantitative measures, the weighted or standardized mean difference is used instead of relative risk. In this case, 0 indicates no effect. If mean difference equals 0 is included in the 95% confidence intervals, it indicates that there is no statistical significance. If not, then the results are statistically significant. This is applicable for the effect estimates of the individual studies as well as for the overall estimate. Whether the intervention is beneficial or harmful depends upon the context. This figure shows the meta-analysis of studies evaluating the timing of cord clamping on cord hemoglobin levels. We can see that the pooled estimate favors delayed cord clamping with a statistically significant increase in cord hemoglobin levels by 0.42 grams per deciliter. So, let us summarize what we learnt from this podcast. We have learnt the different levels of evidence, the concept of systematic review and meta-analysis, and the components and interpretation of a forest plot. We hope you enjoyed listening.